Hi all, welcome to Unfasten Learning Academy. So let's continue with physics questions from AAI ATC. So the first question is, a square sheet of side 5 cm is placed in an electric field E is equal to 1.6 into 10 to the power of 4 Newton per coulomb, such that the normal vector for the sheet is root 3 by 2 I vector plus 1 by 2 j vector. So the electric flux through the sheet they have asked. So the side of the square sheet is given and also the electric field is given and the normal unit vector is given. So as we all know, the electric flux formula is phi E equal to E vector dot A vector into cos theta. So over here the electric field is already given, so we can substitute it directly, and for the area the side is given, so you can just calculate the area by converting it into from centimeter to meter, and then for the theta value they are given the unit vector. So for that we need to find the theta value. So theta is equal to tan inverse of imaginary part by real part. That's the easiest way to remember. So if you just cancel, it will be theta is equal to tan inverse of 1 by root 3. That is nothing but theta is equal to 30 degrees. Now if you just substitute it in the formula, phi E is equal to E vector dot A vector into cos of 30 degrees. So if you just solve it, the answer will be phi E is equal to 34.6 Newton meter square per coulomb. So option B is the right answer. Next question is, a battery with an internal resistance of 2 ohm and EMF of 4 volt is connected in series to a load resistance and the terminal voltage falls to 3.8 volt. What current is flowing in the circuit and what is the value of the load resistance? Now let's just derive this data given in the question into a circuit diagram. So we are just giving the EMF and its internal resistance over here. Here we have the terminal voltage and the terminal resistance. So the EMF formula is E is equal to Vt, that is terminal voltage, plus I into R. Since it's given in series, the current will be same. So we can just denote I as a common value, right? Now if you just substitute it, we can take the small r as internal resistance and RT as terminal resistance, that is our load resistance. Now if you just substitute, I will be equal to 0.1 amperes. Next, we have to find out the value of the load resistance as well, right? So Vt is equal to I into RT. So if you just substitute, you will know the load resistance value. So you can choose the option B as the correct answer for the value of current and the value of load resistance. Moving on. A battery of EMF 6 volt and internal resistance 1 ohm is connected to a resistor of 11 ohms. The terminal potential difference for the battery is. Now we have to again derive this data in the form of circuit diagram. So 6 volt is given and the internal resistance small r is given, and also we are given the terminal resistance as well. So if you just substitute it, E is equal to IR into IR plus I into small r, that is nothing but terminal resistance and the internal resistance. So substituting it over here, you can get the value of I, that will be equal to 0.5 amperes. Now they have asked for the terminal potential difference. So that will be E is equal to V plus I into R, and if you just substitute it in the formula, you will get 5.5 volt. So this is a very basic circuit diagram question, and you just need to know two formulas in order to derive this answer. So the option will be B. Next question is, a circular coil of radius 0.5 meter and 100 turns carrying a current of 80 milliamperes is placed such that the normal to its plane makes an angle of 30 degree with uniform magnetic field of 4 Tesla. The magnitude of torque acting on the coil is. Again, the torque formula for circular coil is number of turns into current into pi r square, that is nothing but the area, into magnetic field into sine theta. So if you just substitute, because all the data is given, 100 turns is the number of turns, I is 80 milliampere, so you just convert it into ampere by putting 10 into -10 power minus 3, and then for r square, r is given as 0.5 meter, so it's already in meters, so you can just substitute it directly, and then 4 Tesla is given, so substitute it here. Then for the theta value, it is given as makes an angle of 30 degrees. So if you just substitute it here and solve it, you will get T is equal to 4 pi Newton meter. So option A is the right answer. Next question is, consider two wires AB and CD of lengths 2L and L and radius R and 2R respectively. AB and CD are made of material of resistivity ρ and 2ρ respectively. The wires are connected in parallel to a battery of EMF E of negligible internal resistance. The ratio of currents through AB and CD, that is IAB by ICD, is. So here we have to note the keyword that is connected in parallel. So voltage will be same. So the current, so the voltage formula is E is equal to I rho L by A. Okay. So since they have given as parallels and since the EMF is equal, you can just substitute it directly over here. So for IAB, you just represent it as here and as given in the question, and for the CD wire, you can represent it as ICD. So we just need to substitute the lengths and the radius respectively, and if you just cancel it, you will get the ratio as 1 by 4. It's a very direct question. So the answer will be C. Next question is, suppose that an alpha particle of 3.20 approaches head-on a lead nucleus, Z is equal to 82, assuming that the lead nucleus remains at rest and the alpha particle momentarily comes to rest and reverses its direction at the distance much more than the radius of the lead nucleus, the distance of its closest approach is. Okay, again we need to substitute it in the formula. So the distance of the closest approach is given by R is equal to 1 by 4 pi epsilon naught into 2 Z E square by kinetic energy. Z is nothing but the atomic number, E is nothing but charge on an electron. So if you just substitute it, the value of 1 by 4 pi epsilon naught is nothing but 9 into 10 to the power of 9 into 2 into atomic number is given already, so 82 into 1.6 into 10 to the power of minus 19 the whole square, that is charge on an electron, and then kinetic energy, it's given as 3.20 MeV, right? So it will be, you have to put this electron volt as 1.6 into 10 to the power of minus 19. So if you just cancel it, R will be nothing but 73.8 FM. So answer D is the correct answer. Next, in a single slit diffraction experiment, a light of wavelength 500 nm is used and the second minimum is observed at an angle of 45 degrees. The width of the slit is. So for this we have one formula, d sin theta is equal to m into lambda. So where d is nothing but the width of the slit and m is the order. Okay. So all the data is given already, like theta is given as 45 degrees, m is given as second minimum, so m is equal to 2, and lambda is given as, it's given in nanometer. So it will be lambda is equal to 500 into 10 to the power of minus 9 meter. Now if you just substitute it directly in the formula, you will get d is equal to root 2 into 10 to the power of minus 6. So that is nothing but d is equal to root 2 micrometer. So root 2 value is nothing but 1.414 micrometer. So option A is the right answer. So I hope that these questions were useful to you. For more such questions, please follow the Telegram channel given in the description, and also subscribe to Unfasten Learning Academy, also known as EULA. Thank you.